Hi guys. So in today's video we're going to be talking about the periodic table, and we're going to connect the idea of periodic table largely with how the nature of metals and non-metals is concerned. So we'll see what the periodic table is all about, and we'll see how the periodic table can help us identify a few things about the overall element. So we know that the periodic table has some of the important features. We're going to be putting a general outlook of the periodic table over here. I'm making three regions of the periodic table. One, this has to be the second one, and this goes for the third one. Let's pick this color perhaps. Yeah, seems fine. Perfect. So this is the periodic table for us. Yeah. Periodic table has been divided vertically into groups. So this is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8 over here. So we have the periodic table over here, TKG. We know that these are the period numbers. Period number 1, 2, 3, 2, then 3, 4, 5, 6, 4, then 5, then 6, and then 7. Okay. So the periodic table has these groups and the periods. The black ones are the groups, and the purple ones are the periods. So let me write it over here. These are the periods. Okay. And we have the elements over here. For example, group 1 in period 1 has only hydrogen, and it has helium in the period 1 for group 8. But then we have other elements, for example, like these. Similarly, we have some other elements which are most common, for example, beryllium in group 2, magnesium, calcium. In group 3 we have, for example, boron in the second period, and then aluminium in the third period. We have carbon and silicon for group 4. We have nitrogen and phosphorus for group 5. We have oxygen and sulfur for group 6. We have fluorine, chlorine, bromine, iodine for group 7, and then we have group 8, which has helium, then neon, then argon, and then so on and so forth. So what we know about them is that the group number and the period number are very much connected with the atomic structure. How is it connected? So when we say group number, the group number tells us the number of electrons within the valence shell. So group number tells us how many electrons are present within the outermost shell, which means the valence shell. So it has the electrons in the outermost shell. How many electrons are there in the outer shell? This is what the group number tells us. And the period number tells us how many total shells. How many shells in total? So let's see. For example, when we talk about any element, for example, when we talk about any random element, for example, if we talk about sodium. So sodium is in group number 1 but period number 3. So we know sodium is in group number 1. So it has 1 electron in the last shell, and it is in period number 3. So it has total 3 shells. So this should be the nucleus of sodium, but sodium should have overall 3 shells. Shell number 1, shell number 2, and then shell number 3. We know that sodium has 1 electron in the last shell because this is the period number. So it has 1 electron in the last shell. What about the previous shells? It has 3 shells, I know this. Shell number 1, shell number 2, shell number 3. It has 1 electron in the last shell. So 1 electron in last shell. But what about the previous shells? So previous shells have a capacity to hold 2 electrons in shell number 1 and 8 electrons in the second shell. So it has 8 electrons in the second shell, 2 electrons in the first shell obviously, but the last shell has 1 electron, and because that's why it's in group number 1. For example, hypothetically we have, let's go for some other element. Let's go for phosphorus. No, for example, nitrogen. Now, phosphorus is also in period 3, so nitrogen is in group 5 and it's in period number 2. So period 2 means 2 shells. So nitrogen should have its nucleus like this. Nitrogen should have a nucleus like this. And then it should have 2 shells. So it has shell number 1, which is over here. And then it has the second shell, which comes after the first shell. So like this. Nitrogen has 5 electrons in the last shell. So last shell has 5 electrons. 1, 2, 3, 4, 5. But what about the first shell? So we know first shell always has 2 electrons. So this is why nitrogen is shell number 1 and shell number 2. And why it has 5 electrons in the last shell? Because it's in group number 5. So 5 electrons in the outermost shell. So one thing is very clear, that the periodic table tells us about the atomic structure. It tells us how many shells will be there and how many electrons will be there in the last shell. So we can pick any element and we can just decide which element is it going to be. For example, randomly, random element X. Let's suppose random element X. Let's suppose X has a nucleus, and let's suppose X has 2 shells. For example, I'm drawing its structure. It has shell number 1 and it has another shell number 2. Okay, let's see how many electrons it has. It's all random. I have the structure with me. Okay, 1 2 3 4 5 6. It has 6 electrons in the last shell. I know 2 things. I know it has 2 shells and I know it has 6 electrons in outermost shell. So 2 shells means second period, and 6 electrons in a last shell means group number 6. So it has to be group number 6 and second period. So second period and group number 6. It has to be oxygen. So I know it is oxygen because it has 2 shells and 6 electrons in the last shell. So the periodic table tells us about how many shells and how many electrons are going to be in the last shell. This is the connection between the atomic structure and the periodic table. In the next video, we'll see how the periodic table tells us about the nature of bonding for each individual element. So stay tuned, guys.